All right, so here is the continuation of the SI session from today. We didn't get to all the topics that we wanted to cover for the rest of the semester, so I decided to make an additional little video explaining a few of those. So we will be looking at a sorting algorithm, and then we will be applying that sorting algorithm to the leaderboard program. I know we have a lot of versions of it, but it's an important addition that I think will be useful. Then we'll talk about separating our programs into multiple files when you have like hundreds of lines and it just all shouldn't be in one file, but actually separated into multiple. All right, so starting off with sorting, in our leaderboard program, the scores are currently ordered in the order that they were added to the file, not necessarily the order of ranking. So we need a way in which we can actually organize our vector so that the scores which are the highest will actually appear highest on the leaderboard. And sorted lists are also useful for other applications. Maybe you want a list in alphabetical order just for output purposes, or in the future, when you guys look at binary search, it's something that you'll see in your textbook, but when you do binary search, you have to have your list sorted. So sort algorithms are pretty common and they are good to know. The one that we will be talking about is called selection sort. There are many of them. I think that this is probably the easiest one, but there are definitely many variations. So if this one is a little bit too confusing for you, definitely take a look at some of the other ones. All right, so now we are going to take a look at what selection sort is doing kind of visually, and then we'll apply this to a program. So here I have two vectors, one of which contains integers and the other one contains strings. You could sort anything that does have like a value which associated with that can be sorted. So of course, numbers, doubles, characters, strings, etc. Those can all be sorted. So let's take a look at what we're going to do here. So the first thing that we are going to do is we are going to start at index 0. It's kind of a common place to start in a vector. We do our print loop from index 0. A lot of things happen from index 0, especially in vectors. So we're going to start there. And we're going to make an assumption. I'm going to assume that the value at index 0 is the smallest number in the vector. I'm going to just make that assumption, and that's it. But I need a way to confirm this assumption. So here's what we're going to do. We're going to say that the smallest element in the vector, we're going to just assume, is 8. We don't know it, but we're assuming. Then what we're going to do is we're going to actually verify our assumption. So we're going to check, is 8 smaller than 89? It is. Is 8 smaller than 880? It is. Is 8 smaller than 211? It is. Is 8 smaller than 42? That was nice. We didn't actually have to move anything. But now we have confirmation that the element at index 0 is the smallest element in the vector. So we can consider this part of the list from here over sorted now. That's all sorted, and we never have to look at it again. Then we're going to move up one index. We're going to look at index 1 now. So we're standing here at index 1. And we're going to do the exact same thing. We're going to assume that the element at index 1 is the smallest element in the rest of the vector, the unsorted part. So we're going to say that the smallest number is 89. Now we have to verify this. So we're going to look up and we're going to check, is 89 smaller than 880? It is. Is it smaller than 211? It is. Is it smaller than 42? It's not. So this is where we have to assign smallest with a new value. 42 takes over the, the reign of the smallest variable, and it now is in smallest. So we've reached the end of the vector. So now what we have to do here is we need to swap 89 and 42 with each other because they are in the wrong places. We know that 42, this one, needs to be here. That's where it has to be. And the only way to make sure that we're not like overwriting anything is just do a swap. It's the easiest way to ensure that everything works perfectly. So what we need to do is we need to do a swap sequence. So what I'll do here is I'm going to create a temporary variable and I'll store the value, the original value that we were looking at in it. So 89. Then what I'm going to do is I'm going to assign 89, the stuff at position 1, with the value of the smallest variable. So I'll just replace this with 42. And finally, I will assign the value, which was the old smallest variable, with the 89. So I'll put that over here. And now we've completed the swap sequence and 42 is in its correct spot. All right, so now from here over on the vector is sorted, and from here over is, we don't know. It could be sorted, we're not sure, but we're going to check. So we're going to do the exact same thing. Now we're standing at index 2. We're standing here at index 2, and we are going to assume that this is the smallest variable in the vector, our 880. So we'll assume that. And then what we need to do now is we need to check this. So we'll say, is 880 smaller than 211? Well, it's not. 211 is smaller. So we'll update the smallest variable. Then we need to check, is 211 smaller than 89? Well, that's also false. So 89 is now the smallest variable. And we have reached the end of the vector. So now we know that 89 is supposed to be here. That's where it goes. So now we need to make that happen. So we're going to do the swap sequence again. So we're going to assign temp with the variable that we're standing at, 880. And then we will assign the smallest, the current smallest, with where it needs to go, right here. And then finally, we will complete the swap by putting 880 here. All right, so now we know from here over is sorted, and from here over, we're not sure. We're standing at index 3 now. All right, so now we are going to make our same assumption one last time, that 211 is our smallest variable. And now we got to verify that. So we're going to look upwards and we're going to see, is 211, is it smaller than 89? It is. So we're good here. We're good. We don't need to do anything. And that's the end of the vector. And we actually don't need to look at index 4 because if everything went correctly in the previous swap sequence, there's nothing else that can be here besides the highest element. So we actually only have to look at the number of elements in the vector -1, or size -1. So now that we have seen that visually, it's time to think about what would you do to code something like this. So the first thing that I think we're going to need is the two variables that are holding smallest and temp. We need those variables. So let's go ahead and start working on this, and we'll come back to what else we need to do in a bit. So right here, I have some code. It's nothing too fancy, but all it does is we have a vector, and the vector is just the values that you saw on the slides, and they're in that same exact order that we were just looking at. And I just have a print function, which is just going through the entire vector, printing each one of them and their corresponding indexes to the console. So I have the unsorted vector, and then I have the, hopefully what will be the sorted vector after we apply the sort function. That's all we have going on here. So here I have the function comment. So we need to write a sort function. So the first thing that we're going to do is figure out, does it have to return anything? Well, when we were messing around with the stuff on the slides, all we were doing was editing the original vector. We weren't expecting any value in return. So I think this is a good one to make type void. And then I'll just give it a name. I'll call it sort. And then we have to give it parameters. So the parameters that we're going to give it, I have specified as the param is vect, and it's the vector to sort. So the vector that we want sorted is nums, and nums is a type int. Whatever this parameter is has to be a vector of type int. We're going to say vector int, and then I'll just call it vect. short for vector, I guess. And now we got to remember, do we want this passed by value or passed by reference? And I think this is a good time for pass by reference. And that's because whenever you pass by value, you're sending a copy to your function. And whatever modifications that you're doing to the variable and the function is just applying to the copy, not to the original. So if we were to pass it by reference, we would sort a copy of the vector, but the original would remain unchanged. We want to make sure that the vector that we are sending up to the function is the same vector that we have in main. All right, so now let's go ahead and work on writing this. So we have our function header right here, and we can define it down here. All right, so there is our function. So the first two things that we talked about needing was a variable for the temporary storage and a variable for smallest. Int temp and int smallest. So now let's go take a look at what else we need. So next thing that we need to think about is how are we going to be moving down this vector? Because we were looking at each index until the last ones. We were looking at each index to size -1. And usually when you are quote unquote iterating through a vector, that means that you're going to use a for loop. So let's set that up. We need a for loop to iterate through each index of the vector -1. So to set that up, I'm going to do for. We start our indices at 0, so I will start at 0. I is going to be less than the vector dot size -1, because we don't need to look at that last element because we'll already be sorted. And we're going to do I plus plus. All right. So that is what we were doing when we were just looking at each element in the vector. But we kind of were doing that twice almost. We looked at index 0. We started at index 0. And then we had to verify that it was actually the smallest. We assumed that 8 is the smallest, but we have to check it. So we're going to look forward over and over and over again. And then we had to do the same thing for 42. We had to look up like this. We had to iterate through the vector again. So this sounds like a good case for a nested for loop, because we are going through each index, but every time that we're looking at each index, we're also looking at each index. It's a complicated pattern, but this is a good case for a nested for loop. So I'm going to put another for loop in here. And I have to make sure that my variable names are different. So the convention is to use I, J, and K. So the next one in order is J. So we'll say that J is going to start at some value. It's going to continue to some value. And we were moving upwards in the vector, so we're good for J++. So now we got to figure out where are we starting and where are we stopping. And this loop is going to take care of checking to make sure that the one that we had assumed to be smallest is actually the smallest. So let's take a look at our slides again. If we were checking for 42, if we're standing at index 1, standing here at index 1, and we need to check that 42 is the smallest number in the vector, the indices that I'm looking at to check this are this one, and this one. I'm not looking backwards. I am looking one more than the index I'm standing at. I'm standing at index 1, and I'm looking up to index 2, then 3, then 4. So I'm starting one more than where I am. So if where I'm standing is referenced by I, then where I need to start looking should be I plus 1. And that's exactly what we're going to do here. We're going to start looking for competitors for smallest at I plus 1. So we'll put that here. J is going to start at I plus 1. All right, and then where did we stop looking for competitors for the smallest spot? We stopped when we had reached the end of the vector. If we're standing here at 42, I'm going to look at this one. I'm going to look at this one, and I'm going to look at this one, but I'm obviously not going to go further than the vector exists, but I have to look at the last one. I have to look at this one, I have to look at this one. All of those have to be looked at. So I'm going to go to vect.size -1. Actually, not -1. We have to go all the way to the end. My mistake. Somehow I still wrote -1 here. I fix it later on, so just hang on. All right. So another thing that we have to do is we have to assign smallest with a value, so it can have the competition later on for who is going to be the smallest in the vector. Remember, when we were starting at a new index, every time we started a new index, we assumed that it was the smallest. So we need to do that. So we will assume, this is where we're looking at the new indices for the smallest vector, our smallest element in the vector. We are going to say that smallest is going to be assigned with I. We're just going to assume that smallest is I. That's it. All right, but now we have to actually check that. So now we have a loop which is going to check, it's going to allow us to look at each index. We actually have to do the checking parts. So we're going to say if, and then we'll say vect.size at j, if that is smaller than vect.at smallest, then we have a new smallest value, because vect at j, this is j, is smaller than vect.at smallest, the position that we previously thought was the smallest in the vector. So now you're going to say smallest is going to be assigned with j. All right, so then finally, by the time we reach the end of this for loop, when we reach here, we'll know what is the smallest in the vector. And we need to do that swap sequence that we did after we were sure of what's the smallest. So to the swap sequence, we said that temp was going to be assigned with vect.at I. So this is the initial position that we were standing at. Then vect.at I is going to be reassigned with vect.at smallest. This is the new smallest value that we could find. And finally, we got to finish that swap sequence by assigning vect.at smallest with temp. Whoops, I put the -1 over here. We definitely don't want that, because we need to look at the last index for potential competitors for smallest. So let's go ahead and remove that and check and see if our program works. We have uncommented the function call. So nums, the entire vector, will be sent up here. We'll execute this sorting sequence. And then hopefully when we run this program, we will see the sorted vector. And there it is, the unsorted vector. And then after calling sort nums, we have the sorted vector in the same order that we saw it on the slides, using the exact same sequence, just in code. Quick little side tangent, I guess. If you wanted to sort from greatest at the lowest index to smallest, it's a very simple switch. All you have to do is you switch the direction of the inequality sign. So now you're looking for the biggest element instead of the smallest one. So technically you might want to change every instance of smallest and then switch it to greatest, but just to show you guys that this works. There we go. Now we have the biggest one at the top and the smallest at the bottom. So now what we want to do here is we want to take this and apply it to our leaderboard program. All right, so here is where we left off with the leaderboard program earlier today. So I'm going to compile and run it just to show you what we have. I added a few more players to the file, but I want you to notice that they are organized in the order that they were added. The first player that we added was Steve, then Bob, then James, and then I added player 1 and player 2 to the file to just emphasize the point that these scores are not even close to being in order. So what we need to do is we need to use a sort function, which is going to actually organize our values here so that the player with the highest score appears at the top of the list. So to do that, we are going to just quickly write our sort function. So it's going to be of type void sort. All it needs is the vector, and it's of type leaderboard. And then we can define our sort function. So I'm going to actually steal the code from the last one, and we'll just make a few quick changes to it. All right, so I'll paste that here, and removing the stuff that's for that function, we have, instead of smallest, we're going to want largest because we want the largest one to be at the top of the list. So I'll just switch all instances of smallest and change it to largest. In the previous example, we were looking at a vector of ints. In this instance, we're looking at a vector of objects. So when we say vect.atj, we aren't looking at a single number, we're looking at a whole object there. So when we do vect.atj, we are looking at an object in which we have a score and a name. But all we want to look at is the score. So we need a way that will allow us to access the score there. So we actually are comparing the score rather than the entire object itself. So if we scroll up here to our class definition, we have a function called getScore, and this is a getter function. Its entire purpose is to allow you to access one of the variables within your class or within your object. So we're going to make use of that for sure. So if vec.atj is an object, we can apply a member function to it by using this dot operator. So we'll say vec.atj.getScore, and this is going to allow you to access just the score. And then we want to do the same thing here because we want to compare the values of the scores. So getScore. And then this is all good because we want to swap the entire object rather than just the scores, because we want the scores to be associated with their players still. Instead of just swapping the score pieces, we need to swap the entire object. So that's all fine. All right, and then another thing that we have to change actually is this temporary variable. Because our temporary variable, we're assigning it an object. And temp is meant to be an int here. So we have to make sure that the temp is the same type as whatever we're assigning it. And what we're assigning it is a leaderboard object. So we'll change the data type to leaderboard. And then facing some of the dangers of copying and pasting, in the previous program, we used vect as our vector name instead of player. So I'll just change the parameter to match that so it's at least defined. Okay, and we'll change it up here. All right, now let's see if it works. All right, no errors. Look at that. There we go. Now the scores are from the greatest score all the way down to the lowest score. And no matter how many times you run this program, as long as you have the sort function called in the program, near the top would probably be best, it will sort your vector.